Jingle bells, jingle all the way. Okay, this is the Christmas special. Are you ready? This is From the Basement. It's the only blockchain podcast that interviews the forgotten and the downtrodden devs that actually do the work. And it's hosted by me, Martin G. And today we have a developer who arguably could neither be described as forgotten or downtrodden, but I'm very much looking forward to talking to him. We have Mike Hearn.
Thank you. Yes, I'm not forgotten or downtrodden, pleased to
say. Mike, I first met Mike actually at not my first or my second Corda meetup, but my third Corda meetup, which was the great which was the great Corda pub quiz. The Corda pub quiz.
Yes, the pub quiz. I remember.
Where I discovered that there at the time, back in 2017, 18, early 18, there were zero Corda developers in London who didn't work for either RBS, one of the banks I had helped design it, or for R3. So that was why I set up Corda Code Club. Yeah, Mike very kindly came along. I grabbed a selfie with him, which is still a treasured possession of mine. Yet to print it off actually and stick it up on my trophy wall. But it's nestled in there on my iPad. And I cannot wait to talk to him. So let's stop me talking and let's run through these 20 questions, shall we, Mike?
Sure. Let's get started.
Let's do it. Okay. Favorite question. What company do you work for?
No, I worked for R3. Yes.
This is a really good question. What do you do there?
What do I do there? Well, I've done a bunch of things there. Currently, I'm leading the Conclave project, which is R3's second platform, in effect, and it's actually a spin out of Corda. It's built primarily for Corda, and it was, designed to become a component of that. But it's also a separate platform, separate product you can use independently. So what do? I do everything from coding to design to documentation to talking to users and helping them with their problems to doing this kind of thing as well. Do a whole lot of different things.
What's the favorite part of what you do for R3?
I'm not sure I have a favorite part. I enjoy all of it. I enjoy talking to customers and, talking to them about what the products can do and what their problems are and how to fix them. I enjoy the coding. These days, I tend to spend more of my time on things like, making samples and documentation and things, because I feel like that's, one area where I can try and keep the products really good, at least on Conclave. And then I program. I enjoy writing code as well. It's all of it.
Okay. How old were you when you started programming?
I was 6.
No, 6.
Yes,
oh, come on.
Yes, 6. Yes,
all the other ones.
Yes, and
what
now I'm 30.
Mean?
Now I'm 36 years old, so I can actually say I've been programming
the
for 30
age.
years. Yeah, amazing. You don't look a day over 20, Martin. Time has been good to you. Yeah. So yes, I've been programming for 30 years. So it was a great time to be born if you're a guy like me in the 1980s, because we had these great little computers like the BBC Micro and things that were easy enough for children to learn. Well, maybe it's still the case, but certainly computers got a lot more complicated since then. And you get this a lot, right? You often talk to people who say, well, I started programming when I was a little kid and because I had a Commodore 64 at home or whatever.
I mean, like my only experience when I was 6, we had an Amstrad, and I remember hitting Control or Enter to start Harrier Attack, or one of the other Amstrad games, or Control or Delete, I think, to end it, and then sitting there watching the cassette tape buzz, whir, and grind about, and then turning it around. But what do you mean? Come on, so you're 6 years old.
Yeah.
Like you carried on steadily to, spending more and more bits of spare time writing it, or then put it down and then pick it up more seriously?
I was more or less continuous. I've always, I've probably been doing something with computers, not every day of my life since, but most of them. I played a lot of games too. I didn't only do coding. I also watched cassette tapes spin. And, as like most kids, I was I was pushed forward because I wanted to make games. I thought games were amazing and I loved them. I loved playing them and I wanted to make them, but I didn't know how. So that kind of, motivated me to learn.
And were your parents supportive, or were they sort of saying like, "Oh, we just can't get little Michael out of his bedroom. We're worried about him. He's going to go blind."
Yeah, well, both. Yeah, so my mother worried about that. She was like always worrying, like, why aren't I going out and frolicking in the fields like a Victorian child would? And I was like, Mother, I don't go outside of football because I live in the northwest of England and it's always pissing with rain and really cold. So, there's a very simple reason for why I stay inside where it's nice and warm and play with the computer. I was very lucky. My father was interested in computers. He ran his own software company in his spare time for a while too. He wasn't actually a full-time developer at any point because he worked in the TV industry instead. But he was there right at the beginning. So there were always computers around the house, and learning to program is really hard, and doubly so if you're 6 years old or 8 or whatever, in those years. But I was lucky in that he would take his time in the evenings and at weekends to sit down with me, and we'd do programming together, and he would show me, what I was doing wrong and fix bugs when I couldn't make it work. And he bought the tools as well. And of course, in those days, the computers and the tools were very expensive. So, he was supportive in that regard. And my mother, she never, I think she didn't really understand for a long time if it was really going to be valuable or if it was just a kind of a hobby. In particular, when I was playing with open source software and Linux, right? She didn't really understand that. Like, why are you giving software away for free? She understood it had value, of course, because Bill Gates and all that. But this whole notion of like open source software was very strange, and that took a while. But they were both very supportive, I think, in the end. I was always allowed to spend this inordinate amount of time mucking about with computers, and even if sometimes my mum worried a little bit, she never really stopped me.
Cool. Yeah. Well, right. Do you have a nickname?
No. It would be cool to have one, though. I would like a fighter pilot name. Those guys have it sorted. Yeah, the call signs and stuff. Yeah. But yeah, we don't do that in the software industry. So.
You don't have like Iceman.
Maybe one day if I'll join the military, just so. Yeah, exactly. Maybe one day, I'll join the Air Force just so I can have an awesome nickname.
Yeah.
But, no, sadly, I don't.
I bet I can think one up for you, Mike. Don't worry.
In the old days, on IRC, we all had nicknames on the old days of internet relay chat. So I was Tweedledee on those networks.
Tweedledee.
Yeah.
Now I want to ask you about what everyone else was called. But let's move on. Where did you grow up?
Well, I said already, I grew up in the northwest of the UK, so near Manchester. Actually, in a town called Macclesfield, which is famous for nothing, basically. It's famous for in the Victorian era that was filled with silk mills and stuff. So yeah, I grew up in the UK in a wet and rainy place, which probably indeed helped motivate my interest in computers.
Where did you go to uni and what did you study?
I went to University of Durham, which is in the northeast of England, and I studied computer science. They actually, there's this sort of educational fashion for a long time to say that specialism is bad. So in the first year, they said you're not allowed to study computer science completely. You have to pick 2 other subjects as well. The same thing at A-level, right? I was the first year where they said 3 A-levels is too specialized. You need to do at least 3.5. They introduced the AS level that year. So I also studied so I did an AS in psychology, and at university the first year I also did history and archaeology.
Oh, really?
So what I wanted to study was computer science. Yeah.
When did you start working in software?
I started working in software when I was 18. So I after high school I took a gap year, and then after having decided I was going to take it, I realized that gap years weren't actually about spending a year traipsing around Thailand and like building canoes and things, which I guess is what I thought it was about at that point. So I started to realize, all right, you can't actually do that. So I looked around and applied for jobs or gap year positions, and I ended up at Kinetic, which is a military contractor. It's actually a privatized part of UK military research around that time. So I spent a year working there, and I worked there in the summer holidays as well. And at the same time, actually, so when I left Kinetic at the end of that gap year and I went to university, I also I'd been involved in Linux and stuff for a long time, and I'd ended up gravitating towards a project called Wine, which lets you run Windows applications on Linux. And at university, I was hired by a company that made a commercial version of this open source project, Wine, and they paid me on like however many hours I could provide basis, which was really great for a student. They didn't pay me very much at the time. The thing is, at the time, I had no idea how much programmers earned. I had no clue at all. No one had ever talked to me about that. For whatever reason, I never researched it. So I went to this conference just as an individual because this company paid my airfare, basically. So I was like, great, I'll get a free trip to America. And then while I was there, the guy who ran this company took me to one side and said, would you like to, work for us? And I said, well, I'm a student, so I can't really take a full-time job. And they said, no problem, you can just work whatever hours you've got. And then he said, how much would you like to be paid? And I was like, I don't know. I said to him, I said, honestly, you've got me at a disadvantage because I have absolutely no idea what number to specify. Yeah. So he said, well, how about we pay you $25 an hour? And I was like, wow, that's loads. Great. And eventually, at some point, I discovered that the other guys who were working there were earning like, I don't know, 150 or something. More than that sometimes. So I was like, wow, okay. I am being very much underpaid. But of course, the flip side was that, if I couldn't do any hours in that week or that month because I had schoolwork to do, then it didn't matter. So I was earning a lot less than the others in that company were, but I had a lot more flexibility, and it still was better than a student job that I would have had normally. So yeah, more or less continuously since 18, actually.
I spent 2 years washing up. Which industry have you spent most of your career in?
Well, that's a bit redundant, right? Given the answer to the last one, I spent all my career in the software industry.
But has there been has it been software for finance technology, software for?
I see. It's been a mix. So I spent many years at Google doing a mix of things there, but that's consumer, online services. So I worked on Maps and Gmail and account system and a bunch of things. Anti-bot detection was one project I started and ran for a while. So I did a bunch of things there. And of course, in R3, it's sort of business to business, it's enterprise, it's banking and logistics and other things. And then at Kinetic, it was, military. Well, it was actually a mix. So we did some military work, but we also they wanted to get into the consumer space too. So we actually built a very early, one of the projects I did there was a very early version of WhatsApp, but it was at a time when 3G was brand new and most people had very, very little data quota or none, and it was incredibly expensive. So, and the smartphones didn't exist. This was before the iPhone. Or they existed, but no one had them really. So we made this kind of app where you could take photos and set them as your status picture, and you could set an emoticon to show your current emotion, and it was a bit like a status wall of how your friends were feeling and stuff. We wanted to add some messaging. The problem was it was just so expensive. It was more expensive to do this with data than like sending text messages. So it was too early, and that project never really became successful.
What's your operating system of choice?
I use macOS. It's not really, well, and I usually have a Linux VM open as well, so I guess I use macOS and Linux. But yeah, it's not, I have my issues with it, but it's, basically solid, and I don't spend much time messing with it, so it gets the job done.
What's your programming language of choice?
Well, of course, everyone who uses Corda knows that. That's Kotlin, at the moment at least.
Oh, at the moment.
Well, when I first found Kotlin, I started writing about it. It was really early. It was before version 1.0 was released. And I said at the time, I was like, I think this is a really good language, and I think it'll probably be my default language for the next 10 years or so. And that was my intuition based on like how long these things last. And I was like, yeah, after 10 years, maybe there'll be something better coming along, and I'll take a look and so on, but probably not. So it's now 5 years. It's now 5 years in, and I'm still thinking it's great. So yeah.
So JetBrains is on five. They've got 5 years notice then, basically.
Yeah. They've got, if they can keep the crown for the next 5 years, they're doing really well. Yeah.
There you go. Gauntlet, phone down, JetBrains. Hope you're listening. When was the last time you wrote some code, and what did it do?
Like a couple of days ago. And what did it do? It printed better error messages in a certain error case in Conclave. It's very simple. I wouldn't say these days I churn out huge amounts of code. Because I don't. I'm mostly doing bits of pieces of things. But that was the last bit of code I wrote.
What's your favorite kind of music to listen to whilst you code?
Drum and bass. Of course, drum and bass.
Go on, give us some artists.
I like liquid drum and bass. So what do we got? We've got Blue Martin, we've got Etherwood. I mostly listen to internet radio when I'm coding. I listen to bassdrive.com, and they have a bunch of different shows with different styles. But it's actually not just me. Dave Hudson, who's the current head of engineering, and he's sort of head of engineering for Corda, he also listens to drum and bass when he's working. So this is a very common thing, actually.
You're not a drum and bass pariah in the programming world.
No. It's that's what he says, and it's good because it's very energetic. So I don't drink coffee, but I do listen to drum and bass, and that's sort of puts you in the flow. Yeah, it's a getting things done music.
Name one skill all programmers should have.
Oh man. Well, beyond programming, you mean? No, I said
oh
man. No, I said oh man.
This is
I was thinking, well, beyond programming, obviously, I would say back of the envelope estimation. It's a very common. So I come across this problem again and again. It's one of the skills that I didn't really have actually until I was at Google, and then the very senior guys there, they did a bunch of talks where they were like, "You really need to learn this, and here's some cheats and stuff that we prepared for you." Which is, someone says, "I want to solve a problem that's roughly this big," and then you want to very quickly figure out what do you need to solve it. And it's just doing back of the envelope calculations. You don't have to get the exact correct answer, but if you understand the orders of magnitude of what things cost, how fast can a hard disk move its disk head? So how many times a second can you read things from random locations on a hard disk? How much RAM what does RAM cost? What does a CPU core cost? How slow is an access to L1 cache versus L2 versus L3 versus DRAM, and what's the ping time? How long does it take to send a packet from Paris to New York and back again? There's a lot of these sort of basic numbers that all programmers should know. And you can find cheat sheets of these online. But the reason they're useful is very often what I find is people come to me and they say, well, we need a system that scales very well. We need it to run over like infinite amount of hardware, right? We need a system where we can just keep adding hardware indefinitely to scale up our application. And the problem with that is it's very hard to build. It's sort of like saying it's sort of like a lot of programming tasks you can draw analogies with organizational tasks. So it's sort of like saying to solve this business problem, we need the ability to hire and add people to the organization indefinitely, right? With no bottlenecks at any point and where everyone is always working at full efficiency. And that's really hard. Very often companies bottleneck on key managers and stuff. And it's the same with programming. And then when I sit down, I say, well, how many customers do you have? How much data are they producing and stuff? And we do the sums. It turns out that one machine is enough. And that simplifies things a lot, right? And then you say, well, so it's nice to be able to never have to think about capacity. People really don't want to hit a wall where they can't add capacity easily, right? They don't want the business to ever be constrained by technology decisions. But often when you just sit down and do the numbers, you say, is there any plausible universe in which you suddenly need a larger computer than this? And maybe the answer is yes, if they wipe out every single competitor they have and get a monopoly in their industry, right? And you're like, yeah, sure, like that could happen, I guess. But if it does, then you'll have enough money to redesign this IT system, so you won't care. And for anything more than that, you can simplify a lot and drastically increase your chances of success and reduce your costs just by running it on a big computer, right? So the industry has a big problem with over-design, where people create software systems way more complex than are really necessary, because they're not doing these back of the envelope, like quick estimates up front.
Yeah,
that'd be a skill, I would say.
I see that a lot. I see. It's amazing how many companies have started using like Kafka or this is low latency. Like, what you mean? Your system that sells carrot peelers.
Right. Yeah, a lot of these systems have their place, but often they've been created by companies who deal with they often do have a monopoly because there's some sort of social network that has achieved lock-in or whatever, and they serve like 1 billion users or whatever, and then you're like, yeah, sure. Then at that point you need to pay the cost and complexity of doing these. But if you're not in that sort of industry, and most companies are not, right, they aren't realistically going to suddenly within the span of 6 months dominate the market and have 1 billion users, right, and have no competitors, then it's that it doesn't make sense.
Agile, is it a force for good or for bad?
force for good or for bad. So, there's certain aspects. I mean, it's such a vague thing, right? There's certain aspects of it that I think make a lot of sense. Regular releasing, being able to quickly and easily update, the software people have, especially in consumer cases. Agile in a lot of companies turns into this kind of set of rituals almost, and it's a set of project management techniques. And there I'm not a big fan of a lot of it myself. I tend to have a fairly minimal usage of it in the projects I run. There's a lot of, people can make it very complex with like story points and epics and all this, there's a lot of jargon in what Agile has become. Whereas I say, like, just give me a bug tracker and let me mark bugs, features, and that's all I need. In particular, there's sort of very inflexible ways in which sort of projects kind of being managed isn't that great. The other problem is that, when you get a sort of very professionalized setup where there's like product managers and project managers, and then programmers are sort of just turning tickets into pull requests, and then there's there's a very stylized way of doing things. It's very easy to lose the long-term view, and in particular for developer platforms, it's hard to be agile because the users are not humans. The users are other programs, and those users are in effect not flexible at all. So they're really exposed to very minor changes, breaking things. Whereas, if you're making a social network or a chat app or even a business app where the users are just, people and they're clicking buttons and things, if you change the color of the buttons, no one cares, right? They'll just like adapt. But if you do that, the equivalent of a cosmetic change to a developer platform, everything breaks. So the whole agile mentality of constantly iterating and tweaking things to try and, make something 5% better doesn't really work with developer platforms. It's too expensive. So, yeah, I would say it's not a force for good or evil, but I personally use less of it in my projects than most people do.
Killer question. Do you or have you ever owned any Bitcoin?
Yes, I've owned Bitcoin. I don't own any anymore. I haven't done for years, but yeah, of course, for a long time, I had a big pile of Bitcoins because I got in early and believed in the project. But sometimes people say, "Oh, you sold your Bitcoins and then the price went up a lot, and wasn't that kind of stupid?" And I was like, "Well, when I bought them, they were worth a little less than $1. By the time, I left Bitcoin and was done with it, it was like, I don't know, 200, 250 or something. So I was like, yeah, show me, how many of you managed to get investments that increase in value by 200-fold? Not that many. But the other problem is, it's this sort of thing, it carries a sort of underlying premise that there's no criteria for selling. So one of the things I did when I first started owning Bitcoins is I said, well, I have no idea what's going to happen. Anything could happen in the future with the value of these coins. It could go to the moon. It could just fizzle and die and into obscurity. It may not get mass adoption, and who knows what can happen. So I said, I'll keep these until I did. What's the criteria for selling them? The obvious one is no criteria. Just hold forever in the hope they always go up in value. But that's not a very
If you never realised the value, they're worthless.
Well, right, yeah. At one point, you've got to actually swap them for something useful. Otherwise, you die poor but rich, which makes no sense.
Yeah.
And then the other one is you don't know what's going to happen. So I just said, well, I'm just going to sell them when I stop being involved in Bitcoin. It's an entirely arbitrary criteria, but it's less arbitrary than some others. I'm not going to try and do day trading and try and guess the ups and downs because who knows, right? It's pretty volatile. And that's what I did, and I have no regrets because. If I hadn't done that, then I would have no criteria for deciding when to sell, and it would be illusory wealth. Right? You'd always be holding in the hope of a better tomorrow. Never use it for anything.
That's the one thing. Like the one message I've taken away from my dabblings in the world of Bitcoin and cryptocurrencies is hindsight is 2020.
Well, yeah.
and I'm never going to be a day trader.
No, I'm not. I'm not big into that either. I think you want to look at long-term trends when you're doing this kind of investment.
Yeah. Right. Now I've got a whole bunch of questions about Corda. I'm not going to ask you how long you've been using Corda for, because it's obviously going to be since day one. Here we go. This is a good one though. Why did you get into Corda?
I'm obviously not going to answer that. The question is why did I create it? Right? Why did I start? Why did Corda get into me? Right, at the end. So after 5 years of Bitcoin, I concluded it wasn't going to work because that community was being taken over by people who basically didn't believe it should be mass adopted, which was the original goal of the project and why I got involved and why a lot of people got involved. We wanted to be able to buy things in our daily lives with Bitcoin. and we wanted everyone else to be able to do that too. And that was that community was starting to lose confidence in that whole mission statement, and Satoshi wasn't around to, say, look, I'm the boss and this is what the goal of the project is. So I left that and was looking around, was thinking, what do I do next? And I'd started reading about banks and other organizations that were experimenting with the technology, but it was all very isolated. So you'd read about like individual companies, and they would announce, they'd do a press release saying we experimented with Ethereum or whatever. And I thought that's pretty useless, because the whole point of Bitcoin is or the whole point of a blockchain technology is to coordinate multiple organizations or people. So if you're doing it on your own, that's kind of missing the point. So I kind of ignored that. And then what happened at the end of 2015 is I started reading about this company R3, or this consortium called R3 actually, where they were bringing together a lot of banks, and it was basically being created by banks and other organizations to do group experiments. And at that point I started thinking, oh, okay, that makes a lot more sense. Now they're getting serious about using it to, do peer-to-peer networks between each other. Suddenly this is more interesting. And I figured, well, I'm leaving Bitcoin, but I'm left with a lot of knowledge about this technology and how it works. And I don't think their experiments are going to work, because I don't think Ethereum or Fabric are good enough. So as fortune had it, I had met Richard Brown at the Swiss embassy, which I've been invited to basically because I live in Switzerland, and the Swiss embassy in London actually wanted to host a kind of a blockchain evening for people to talk about, blockchain and whatever. So anyway, I said, yeah, I'll go along to that, because I'm going to be in the UK anyway to see family and things and friends. So I went to the Swiss embassy and was on a panel there, and one of the other guys on the panel was Richard Brown. And I noticed on his name badge, I thought he worked for IBM, and he had just switched that week to working at R3. And I was like, oh, this is the second time in about like 3 weeks I hear this name. And Richard is a smart guy, so we talked a bit. And then some weeks later, I called him up and said, look, do you realize that what you guys are going to do isn't going to work because the tech isn't good enough? And he was like, well, maybe. So we started talking. I came out to London and spent some time and met Richard and David and James and the others, and basically made that same argument. And I was pushing on an open door. I think they had concluded the same thing by that point, and that was why there was an architecture working group, which was charged with creating requirements and designs for a bank-grade blockchain. And so I decided, well, all right then. I mean, this is a chance. I think they need something started from scratch, basically, and this is a chance to do it. So let's get started. And that's how Corda came to be.
That's how the dream was born.
Kind of, yeah.
Here we are. I want to ask you what is the best thing and what is the worst thing about Corda?
The best thing, I guess, is that I think it's the most successful attempt to balance the spirit of decentralization that animated, all the classical blockchain projects like Bitcoin and Ethereum, this sort of pure desire for true decentralization, but it balances it with classical enterprise engineering requirements and the sort of enterprise culture that exists in large organizations, right? Which is not that easy to pull off. And what you see in many projects is, like if you look at Ethereum, they're really not interested in the needs of solid, stable, pre-existing organizations, right? They're not interested in the culture that has grown up over time in response to various needs. Like security, like auditability, like the ability to have developers who are business domain experts work with it and work with existing technologies and skills. And I think Corda is, I think it manages to do that. I think it's enterprise software, and yet at the same time, it hasn't forgotten its roots, right? It hasn't forgotten about, where did this all start? How did this come to be? So I think that, and that's a pretty vague thing, right? But I think a lot of what's in Corda follows from that balance. And then the worst thing, well, this is pretty tricky, obviously, because I'm criticizing my own product basically.
It's actually perfect. I made it, don't you know?
No, it's not. It's not. So I would say my personal regrets is sort of Corda was built quite quickly, right? Because we started after other platforms like Fabric and other things. I felt and Ethereum have been around a long time as well. I felt that their designs weren't that good, but starting from scratch, basically, I started coding it on my own as the only programmer on the team. There was no team that had to be hired. Richard and James had a few very initial design thoughts, but we had to go quickly, and you can see that in parts of Corda's design. And we were developing it in parallel with developers who were saying, oh, this looks good, we're going to start using this. And they started building apps and prototypes on it as we were designing and building the platform. So it kind of evolved alongside its users. And then at some point we had to draw the line and say, yeah, the design isn't really perfect. There's a lot of like rough edges here or there, but we have to freeze this so people have stability and we're not constantly breaking their apps, because they need, they want to go forward and actually turn these into real products. They're not going to, they want to leave the prototyping phase. And this sort of high pressure, high speed development process can be seen in Corda. If you work with it every day, and I think, yeah, in a parallel universe where things had happened in different order or timings have been different, then parts, you wouldn't see that, right? It would be a more polished base product and things as a consequence. But there's actually now an effort that they're starting to look now. And I don't want to talk about this too much because, I don't run this anymore, but they are starting to look now as an initiative to fix some of those things and go back and allow users to opt into breaking changes if they want, where they can port their app to a new version of Corda that's kind of, a bit more polished and things. So anyway, I would say that's the worst thing.
So not as well designed as it could be, not as polished as it could be.
I think it's not so much a core design. A lot of it is like it's the details when you drive in and build apps with it. Some APIs are too low level, others are too flexible for their own good. There are parts of the platform that just are a bit ugly and hacky, and there's a bunch of things where you can always do better in hindsight, right? Like you said, hindsight is 2020. But there's also things where we knew at the time it wasn't really quite right, but we ran out of time. We had to pull the trigger and say, right, we're done with the design phase and we're done with making things for developers. We're now moving on to deployment and monitoring and enterprise capabilities and performance and other things. So yeah.
So thinking back to those early days of R3 and Corda, when you think back on those, what's your most vivid memory of what happened?
I mean, I guess we've got a bunch of memories. So one was, our first users. So Lee Brain and his team at Barclays were the first users of Corda, right? The first time anyone outside our little team had said, right, we're going to build something on it. And there was a kind of a competition, or there was a demo day or something like that, and people were picking their blockchain platforms, and Lee's team decided, right, we're going to do Corda. And at that time, that was really early, because Corda didn't even start up at this point, right? It didn't actually have a node. We've been working on it was basically a bunch of unit tests. So we said, well, okay, so we're making good progress here, but we should really have something. Firstly, there's no user interface, there's nothing to look at, and secondly, there's no node. So we put that together relatively quickly, and I remember spending time building a kind of graphical visualization of like circles flying around a world map, so you could see that as the nodes came into consensus what was happening, and they were stepping through the flows and other things. So and then we had we had a demo, and it looked pretty decent, and there were some nice animations, and you could really see the visualize for the first time, right? You could see what was happening inside the Corda network. And that was pretty satisfying, and in fact they were very happy with it, and that people saw for the first time that Corda is real, right? It's this thing that's being built in response to what we are asking for in the architecture working group, and you can start it up and put it on the screen. So that was where we first started catching people's attention, and they started to realize it was something real.
What was the relationship between R3 and the architecture working group, the AWG?
Part of the benefit of joining R3 as a consortium in those days was the chance to take part in these working groups. So we had, there was not only the AWG, there were a whole bunch of working groups, and the AWG was the one for the tech guys in the banks, basically. And it was pretty straightforward. It took the form of a series of meetings, and they produced white papers, but there was also a mailing list. The AWG had two roles in effect. There was the formal role, which was we have a bunch of meetings and we talk about requirements and we generate white papers that are briefing white papers on what we want from a blockchain technology. And that was, independent of Corda. The whole plan for that predated Corda completely. And then there was the second role, which started after I joined, and I was like, well, look, I mean, I think I understand blockchains and programming pretty well, but I know nothing about investment banking. I've never worked in finance, right? I don't, this is like a new world. And so we set up a mailing list, or I set up a mailing list, and we added all of the architects to it. And I was like, right, this is a discussion forum. And I started just sending mails being like, here's the design I'm considering for a part of our prototype. The prototype is implementing some of the ideas coming out of the working groups, not all of them, but some of them. And I would ask questions like, how do you manage disparate time zones in options contracts? And like quite, they recommended me a book. This has been recommended to Richard, and he read it, and they recommend the same book to me, which is called The Banker's Plumber's Handbook, or something like that. Okay. And it was written by some guy. It was self-published on Amazon. It was written by some guy who worked at Goldman Sachs. But it was this gold mine of information. It was about like, what do investment bankers do all day, actually, and what goes on inside an investment bank, and the processes that they automate and so on. So I read that, and that was very interesting. But there were still a lot of details. So I would get every so often I'd be in London, and I'd get these very senior guys from these major banks. Primarily banks, not always. So there were also financial utilities as well, and they would just swing by the office and basically teach me finance and give me like tutorials in how does a clearinghouse work and things like that, right? And that wasn't really a formal part of their role, but it was very useful. And so we read those white papers, of course, and took that into account in the design of Corda. And so they had direct daily input into the design of this platform. And I think that helped, because they started to see it as like, this is the platform that we are designing for our own use. This is the one that will really meet our needs, because the people building it ask us about our needs and our work and, the problems we face every day.
Yeah. The one thing that Corda has, which the likes of Ethereum and Bitcoin, I believe, don't have, which is one of the bits that makes it hard for people who are moving out of the Ethereum world to move into Corda to get their heads around, is the idea of flows, right? Where did flows come from?
Yes. Flows, right. So one of the last projects I took on in the Bitcoin community was this app called Lighthouse, which is actually it still is. Other people took the source code after I stopped working on it, and they resurrected it. Lighthouse is an app for managing assurance contracts, is their technical name, but you can think of it as crowdfunding. We all pay. None of us pay unless all of us pay, is what it implements, right? So it allows you to commit to paying for something as long as other people do, and once the target amount of funding is reached, then the money moves out of your wallet automatically. It's a kind of a group authorization, right? You don't have to do any second kind of authorization. It just like automatically commits once you've raised enough money. Which is not a very complex financial contract by any means. It's certainly quite trivial by the standards of the banking industry. But implementing this on top of Bitcoin was really, really painful. In a peer-to-peer system, programming it is hard, because lots of things can be happening simultaneously, and they might be contradicting each other. So you have to reconcile this like multiple views of the world. You've got the view of the world that you've put on the screen and that the user is seeing. Then you've got the view of the world the user is trying to set up by clicking buttons and things. And then you've got the views of the world seen by the different peers on the peer-to-peer network. And then you've got in Bitcoin this blockchain, which is like the committed view of the world. And so you've got and then the blockchain can actually roll back and then move on to alternative parallel timelines. So from a programming perspective, this was an absolute nightmare, because you could get and there was this huge variety of edge cases I had to handle when writing Lighthouse. Like, you put something on the screen, and then while the user is in the process of clicking confirm, the blockchain rolls back and moves on to an alternative fork where it never happened at all, and you have to detect that and say, oh, actually, sorry, you clicked the button, but everything is irrelevant now, and now you have to do it again. And it took a long time. It took about 8 months, and the app was quite, when it was launched, one of the top pieces of feedback was like, well, this is good, but it's kind of threadbare, right? It's kind of basic, like where we want more features. And I was like, my God, it took like 8 months of very difficult programming to just give this feature set that you've got already, because it is so complex to build blockchain applications. So when I came to Corda, I thought, well, you know, what these guys on the AWG and these finance experts are telling me is they're talking about apps and protocols that are like 1,000 times more complex than that. They are talking about business processes that make a simple crowdfunding app pale, right, in comparison. And there is no way that we can implement these kind of things on top of a Bitcoin or even Ethereum type system. As is, it would just be a complete nightmare. It'd be far, far too hard for people. So just coding Lighthouse was very complex. The code was very complex because it had to handle all these edge cases. I had to come up with alternative ways of moving data around outside the blockchain. And then, you know, when I started working on Corda and I started talking to the architecture working group and the finance experts that R3 had and so on, it became clear they were talking about applications that were like 1,000 times more complex than that. And a lot of the prototypes they were building were built on Ethereum because Bitcoin just could not do it. The feature set just wasn't there. But even on Ethereum, they had a problem that, you know, the only way for parties to communicate and organize themselves on Ethereum was through the blockchain. So they would, and then everything was public, and it was also expensive because everything was copied to everyone. So it would be like trying to organize the work of the banking system through a global mailing list, you know, Google group with every bank employee in the world on it, and everyone just sends messages to it when they want to do something, right? It just wouldn't work. So the flow framework came out of this view that we needed ways to build very complex protocols and business processes that did not involve touching the blockchain until the right time, and it had to be easy to code because you know, developers were going to be trying to build very complex protocols on top of it in very little amounts of time. So this is one of the reasons why I said to Richard at the very beginning, look, this isn't going to work. Like, Ethereum isn't going to work. Bitcoin isn't going to work. I don't think Fabric is going to work because you need this capability and none of them have it. So that's where the flow framework came from.
Okay, cool. And I mean, one of the things I went to this blockchain conference once, and Richard Crook and Richard Gendal Brown were talking there, and they were both making the point that with Corda, what you can do, which is different from the other blockchains, is so with Bitcoin you've got the money transaction going from party A to B, yeah, and with all these other, like the organic food Providence blockchain app, or the electricity grid blockchain app, you've got the services, the goods and services going from party B to party A. But with Corda, you've got, for the first time, you've got both parts of the transaction, both the payment and the goods and services, being described on the blockchain. So was that specifically intentional, or it sounds like it just kind of came out?
No, it's intentional. So, you know, the point, any database where multiple parties can coordinate a transaction and then commit it collectively would allow you to do that if you have a representation of money and services in the same database. You know, you can imagine that if all banks and companies, and, you know, if the entire economy shared a gigantic, I don't know, Oracle database or something, and, you know, there was a feature in that database where multiple connections could collaborate on the same transaction, right? Which, you know, you could add, it's not like technically impossible, I don't think. Then you would get the same effect. You could do delivery versus payment, in which, you know, the money only moves if the services or control of some other asset moves. However, no one can build such a thing. Well, so, you know, you could argue that some cloud type services like Salesforce and so on are trying to do that. But realistically, you can't do that for the entire economy because, you know, for all kinds of reasons. It doesn't scale, privacy, control, accountability, all that, right? Lots of reasons. But with Corda, you know, the reason the flow framework exists is so you can collaborate on building a transaction. And once it's built, then you commit it collectively. And so at that point, you've got that capability, but it's, you know, in a way that tries to fix the privacy and accounting and scaling issues that you would otherwise have. So it's absolutely intentional. You can do that. That's not something really necessarily specific to Corda. It's just a natural consequence of the fact that it tries to be a general database platform.
I want to ask you about Conclave, okay? But I'm going to ask you this one more question about Corda. The name.
All right.
Where did the name come from? Is Corda your idea?
No, I actually never really that liked the name that much, to be honest.
Really?
The name came out of a Slack poll that I started one night because the code at that point called itself R3 Prototype, which was kind of annoying. In particular, it's very long to type, but it was also obviously not a real name. So I was writing more and more code, and whenever you're writing code, the name of the project ends up in the code a lot for various reasons. So I was like, well, the longer I go on without a name, the harder it will be to rename it when we're done, and the more disruptive it will be. So I just threw it out. I was like, we need a name. I suggest, what did I suggest? I think I suggested Delegato.
Delegato. Sounds pretty pretentious.
And Richard, it was a bit. Richard said, "Oh, it sounds like a brand of ice cream."
It does, yeah.
I think killed that name dead. I won't claim to be a marketing genius by any means. In fact, no one ever likes my names. So we started a poll, and I think Richard suggested Corda, and he came up with some absurd explanation about how it's something to do with chords on a circle. It was some completely backronymed explanation that he made up on the spot. I don't know where the name really came from. And then we had a vote, and there weren't, at the time, R3 was like 10 or 15 people or something. So we just had a vote, and then Corda won. And I was like, all right, fine, it's short, it's easy to type. That's actually the most important thing as far as I'm concerned. Yeah. It doesn't seem to be a trademark. It doesn't seem to mean anything. We can get the website for it, done. Let's do it, move on.
You do realize that it is a trademark, though?
Is it?
Yeah. But there is another technology product that BAE Systems have built, and it's Corda in capitals, and it's some archaic database or something.
There was a product we discovered at some point. I discovered this because someone sent us a security, we run a security program where we reward reports of security bugs, and someone sent us a bug, and they were like, oh, if you run Corda in this way, then there's a security bug. And I looked at the report, and I was like, this, whatever program you're running, it isn't our Corda. And he had found some ancient program that had been acquired years ago, and was no longer called Corda, but an old version of it was, and thought it was ours. So trademarks, well, that's tricky. It was good enough anyway. It was not obviously conflicting with anything else in the space. And then we also had a competition for we had a poll for the logo. It's all very democratic inside the company, at least. And that time I won, actually. The logo that Richard preferred didn't win the poll. The Pac-Man logo, as I called it. I think the moment I called it the Pac-Man logo, people were like, oh, Pac-Man's cute. So we definitely won that one. And then that's how we ended up with this logo. But yeah, and then actually Conclave, before it was called Conclave, I picked the code name for that too, and no one liked that either. So then we had to rename that too.
Yeah.
But it was originally going to be called Oblivion because I thought that sounded awesome, and everyone was like, "It sounds like it will eat your data."
Oblivion, yeah, just chuck your important code in the Oblivion. What could go wrong?
Yeah, what could possibly go wrong? Yeah, so I thought it sounded cool because it's from oblivious computation, which is a term of art in cryptography. But of course, no one else knows that. It just sounds like a black hole. So we changed that one too.
So come on then, tell us about Conclave. Where did you get the idea that confidential computing was going to be interesting or important or valued to anyone?
Well, confidential computing is a very old concept by this point. It's been around a long time. It first started being designed. So Microsoft did the very early designs in the latter part of the 90s in a thing they call Project Palladium. And they worked with the computing industry to introduce Palladium features into the PC platform, which not much of it survives now, but it's still used in things like disk encryption. And like if you use BitLocker on your Windows disk encryption, then that very first early iteration of trusted computing, and as it was called back then, it's called confidential computing now, but it was called trusted computing back then. That's what you're using. And I read about this tech a long time ago, and thought it was interesting and it had potential. But the problem is it never really worked well. It just didn't work well. There were too many cooks in the kitchen, basically. Too many companies needed to be coordinating to upgrade the PC platform in that particular way. Many of them, they didn't, it was being pushed by Microsoft. Many of them didn't see an immediate business case for it because the benefits, it was new developer capability and it changed the way you built software. And so the benefits were quite far out. And it also got attacked a lot back in those days by people who were like, oh, it'll be used for DRM and protecting music. And back then, you know, these days people don't really think about it much, right? The music industry has changed to streaming models and stuff, but that was a huge political fight back then too. And over the years, you know, as companies kept chipping away at this trusted computing thing, and it never really quite worked well enough. And then around 2015 or so, I started reading about SGX, which is, you know, Intel's latest whack at the piñata. And it was convincing for me. For the first time I read about this, and I thought, this can actually work this time. You know, we're on the third iteration of this tech now with SGX, but it seems like, firstly, this is a single company effort now. Many of the previous efforts broke because too many companies needed to coordinate, and it was just too hard, and they weren't all aligned behind the same goal. But for the first time, this is now one company, and they're kind of aligned behind it. There were technical upgrades that fixed problems that have been in previous versions. And at the time, the blockchain community was very strongly behind zero-knowledge proofs and other things like that as the way to get privacy on a blockchain. And I liked those techniques. I've been reading these papers, and they're very clever, but I just couldn't see it. I was like, this is just too complex. I was like thinking, a lot of people were talking about it and making generic statements like, this is the future, blah, blah, blah. And when I sat down and read these papers, and I thought, firstly, can I implement them? No, there's just too complex. There's too much work here. They change constantly. If I did sit down and start coding this up, then by the time I was finished, it would be like 2 more algorithms. You know, everything I'd have done would have been obsoleted already, and some academics would have replaced it with something else. But also, I cannot explain to other people how this works in a way. You know, I just can't explain to them how it works. I understand how it works, but you need, you know, an entire lecture series to show people how this works. And if people can't understand it, then it's very hard to trust it. That's a problem. Whereas with trusted computing, firstly, the banking industry has a very long history with secure chips and trusted hardware. You know, they all use HSMs. The credit cards we all use have a secure chip in it. This is technology that the banking industry knows and trusts and understands at a deep level. And SGX is very similar to that. And secondly, you can use traditional programming techniques with it, and you don't have to, you know, learn totally new ways of writing software that are completely foreign to anything you've done before. So that's kind of, you know, why I concluded that it was time to invest in this in a bigger way. The need was there. The AWG was saying, look, the privacy requirements, even with the tricks we've put into Corda, the design aspects, they're still not quite good enough. We need more. The tech was maturing, and it was a good fit for the customers and the bank and the industries.
You're saying you know, there's a need for it now. You're saying the banks or the customers were asking for more secure thing, you know, doing things the way we'd already do them in a more secure way, or is there anything new?
No, it's everything. It's both. Yeah, it's new things and existing things in better ways. So actually, although Conclave is, you know, the glide path it's on is to encrypt the Corda ledgers, and that's what we hope will be a relatively transparent drop-in upgrade for Corda users. They'll just be able to simplify their apps because they won't have to, you know, come up with convoluted tricks to prevent private data.
You won't have to get a PhD in mathematics and.
Well, yeah, you can just write your code in a straightforward way, and it'll just be automatically, you know, hidden and encrypted and stuff. So that'll be great. But actually, for various reasons, the first thing we're doing is actually adding new capabilities to the Corda platform, which is you can just run arbitrary non-smart contract logic. You can just run any program that's you know, it's not a part of a transaction. On a node on a peer-to-peer network, and then other nodes can send it messages and things through the flow framework and use it to do shared multi-party computations where that hosting node can't see the results or the calculation or anything about it. They just provide the hardware. And this simplifies all kinds of things. For example, if you say I want to run an auction, like a blind auction for something, doing that with traditional blockchain technology and including Corda is really hard because you know, there's no hat, right? There's no equivalent of the hat where you put the bids and then, you know, you sort of any kind of thing where you need a process that's kind of blinded, or you would have to rely on a trusted third party to provide that, right? That can now be replaced by an enclave. And it can be done in a way that's also decentralized, even though the enclave itself runs in a single place. Because you don't have to trust the people who run it. You could just hold a random, you can order a random lottery draw each day to decide who runs it on that day. And it can just move around, right, between a group of people who are collaborating if they all have the right hardware. So none of the parties are actually special, even if on each individual run of a calculation, one of them is running the enclave. It doesn't really matter, right? You can have a decentralized system still. And this is a huge upgrade in terms of what you can do with blockchain technology by integrating this stuff. And a lot of things that were once impossible or very complex or just, had a lot of caveats can now be solved in a really nice, clean way. And additionally, Conclave is not just about Corda. Conclave can be used independently of Corda. So, traditionally a blockchain is an all or nothing thing. You have to build the app from scratch to be on a blockchain platform. With Conclave, you can take an existing app, like a centralized service of some sort that predates blockchain. And you can upgrade it with better privacy and lower trust and even more decentralization, but without, rewriting the entire thing from scratch and, changing things for your users in big ways too. And you can just buy Conclave without Corda if that's kind of more appropriate for what you want to do.
Have you got your mind on, or your heart even, sort of on some kind of like dream use case for Conclave, or something where you're thinking, I wish someone would come up to me and say, we want Conclave for such and such. And you're like, I've been waiting for someone to say this to me.
Kinda, I guess. So, obviously because of R3's background and then our customer profile and stuff, the initial use cases that people are experimenting with are business to business. They're insurance, they're anti-money laundering, all the usual stuff, right? Conclave is a bit different in that you could feasibly use it for consumer tech as well, which is where I sort of started in my post-university adult career, right, doing like consumer services like Maps and Gmail and stuff. So could you now build an email service where the host cannot read your email? And traditionally this requires end-to-end encrypted mail, which is really hard. It's existed for a long time. No one uses it. The usability caveats are far too high. Very few people use PGP and other encryption technologies, right? Even S-MIME. But with Conclave, suddenly now it's entirely feasible that you build a Gmail with spam filtering, with search, with a nice UI that updates constantly. And just ordinary passwords to log in. The users don't need to do anything different. And it's all encrypted and the provider can't see it. Same for a chat service like Slack.
So I could have a Gmail account, and Google wouldn't be able to read my, they wouldn't be able to mine my data.
Exactly. Well, or I
swear in Greek mythology, like the sons eat their fathers.
I guess a little bit like that. So, okay, at this point I have to clarify something. What enclaves let you do is audit. They let you audit and understand how your data is being used because it's encrypted and only the enclave can access it. But that enclave can, for example, decrypt some of the data and give it to the host. So Google could, or any company could make they could still do data mining, right? That's a very vague concept. Like you could think of the spam filter as being data mining based, right? And you probably want that. They could even do advertising. The point is you can see what they're doing, right? So if it's audited and you say, they're extracting my data and they're using it for purposes I don't want, then I can see that and I'm not going to upload my data. And in particular, this means that, for example, that the employees cannot access the data, right? If they want to do something with that data, then it becomes visible to you and you can approve or unapprove it. And that means, a company could offer email accounts with no advertising if they wanted to, and then you just pay for it. Or they could actually still use advertising, but the advertising system, you'd be able to see what parts of the email it has access to, and you would see that the humans who run it can't read the contents of the mails and other things. So it's really about control. It doesn't imply everything has to be hidden. That's just the option.
This is news that should warm the hearts. Do I mind being a prosumer and helping to make Google rich so that I can watch, crap on YouTube? No, I don't. But do I slightly resent it?
Yeah.
Maybe a bit. Does it seem a bit off? that the richest people in the world are making all their money from this prosumer culture, and they're just selling everybody's lives in the way they do. Yes, it does. And then along comes Mike Hearn with his Conclave, and this opening the door to some alternatives, some competitors, some and that's the dream of blockchain, and it hasn't really happened yet. There hasn't been this democratization, this return of power and control to the individual user yet.
Well, I mean, it depends how you look at things like Bitcoin and stuff, right? I mean, there was a phase where it was very much about the kind of a consumer market, right? And it didn't, it ended up being pulled away from that. And Corda has been doing this kind of, democratization for business groups. But yeah, I think in terms of the consumer tech, that's kind of an unexplored area. You don't have to use Conclave to do it, right? Any hardware enclave technology can be used, but Conclave certainly makes it easy. So that's really good. And obviously at the moment, R3's customers are not in that sort of space, right? They're not the kind of people who are making like a Slack competitor or whatever. But what I'm hoping is in future we can do some demos and things and show people this is possible and how to do it. And that will fire the imagination, and some people will come along and start building this kind of, privacy-friendly consumer technology in which tech companies go back to being almost like utilities, like water companies or electricity companies or whatever. They kind of sell us useful stuff, and we pay for it, and we don't really worry about the control they might exert on politics or our livelihoods or anything like that, because they just don't have access to the necessary data to do that.
Brilliant. Right, let's end it on that note, Mike.
All right.
Thank you so much. I wish you Merry Christmas, and I look forward very much to seeing what happens with Conclave in 2021.
Yeah. Merry Christmas to you too, Martin.
You have been experiencing the sweet sound of the final episode of From the Basement in 2020. And to our regular listeners, we thank you for your steadfast support. But, dear listeners, I ask you do not wail or lament the passing of the year simply because there shall be no more episodes created in this calendar year. Instead, you may find succour in listening to the previous episodes, which may be found on Spotify, Apple Podcasts, and YouTube. And take heart and be glad that in the coming of the year 2021, we shall return. This episode was presented by Martin G, Christmas wrapped by Tess Shepherd-Smith, and breathed into fully pixelated festive life by Oscar the Animator Bennett. And it came to you tied with a red ribbon all the way from the basement.